Alright, what's up guys? In this video, going to build some calculus here. It's going to be another integration practice video. This is going to be example number 61. Okay, so we're asked to evaluate the integral of the square root of 196 minus x squared dx. So this is clearly just a trig substitution. If you look at the form that we have the square root of a squared minus x squared. And remember, that's just going to be a sign substitution where x is going to be equal to a sine theta. We now need to determine what a is. So if a squared is 196, then that must mean that a is 14, because if we square 14, we'll get 196. So we'll get 14 sine theta. We know we need the derivative of that, which would be 14 cosine theta. Don't forget to multiply by d theta. And I don't skip steps in my videos, so I'm gonna plug everything in. So get the square root of 196 minus, you stick your x in, which was 14 sine theta squared, multiplied by dx, which is 14 cosine theta d theta. Okay, so hopefully that makes sense. We then go ahead and take care of the square root. So we'll get the square root of 196 minus 196 sine squared theta, because we're squaring both the 14 and the sine. And so with just a little simplification, we'll get 14 times the square root of 1 minus sine squared theta, which we know will just give us 14 times the square root of cosine squared theta. And everything just kind of simplifies out to 14 cosine theta. So now what we do is we go back to our integral. And here's what we got. So we'll have 196 because we'll have 14 times 14. And then we'll have two cosines. We've got a cosine here, a cosine there. So this would be 196 cosine squared theta d theta. You can strip out, or factor out, I should say, the 196. I'm also going to rewrite cosine squared theta using a half angle identity. I'm going to pull out the 1/2, and then this just leaves us with the integral of 1 plus cosine of 2 theta d theta, because we use the half angle identity for cosine squared theta, which is 1 plus cosine of 2 theta all over 2. So all I did was just strip out the constant, or factor out the constant of 1/2. 196 times a half, that's 98. So go ahead and simplify the constants on the outside here. If we integrate 1 with respect to theta, we'll get theta. And then if we integrate cosine of 2 theta with respect to theta, this will give us 1/2 sine of 2 theta. Tackle on plus c. Alright, so hopefully you're with me so far on how I got there. But we're not done. Still got a lot of work to do. So the first thing we need to do is to rewrite sine of 2 theta, which is a double angle identity. I can simply write that as 2 sine theta cosine theta. So now what we have is 98, which is on the outside there. We'll distribute the 98 in once we get to the end. Some people like to take care of the constants and distributing and stuff like that a little earlier in the process. And you can do that as long as you're careful and still get the right answer. But you definitely want to make sure you're taking your time. And I always wait to the end to deal kind of with all the mechanical stuff. So then again, this is just theta, and this would be plus 1/2 multiplied by 2 sine theta cosine theta. So maybe you don't do it in as many steps as I do it. Maybe you do it slightly differently. Whatever works best for you is fine, as long as you're doing it correctly. Okay, so we need the trigonometric ratios for sine and cosine. So we just use a little bit of trigonometry, particularly with right triangles and Pythagorean theorem and that sort of thing. So recall that if we go back to what we have, that x was equal to 14 sine theta. So that means that sine theta is equal to x over 14. We also need to get theta. So theta, that's inverse sine, or sine to the negative first, arc sine of x over 14. Now we need those trigonometric ratios for sine and cosine. I'll put it right here. Actually, no, I'll put it right here. That way I can see it. All right, so let's go back to SOHCAHTOA. Okay, so recall that sine theta, that's opposite over hypotenuse. And remember that cosine theta, that's adjacent over hypotenuse. Okay, so if you look at what we have when we solved for sine theta, using the substitution that we did, we got sine theta was x over 14, which means that sine theta, which means that the opposite side of the right triangle would be x, and then the hypotenuse would be 14. Now we do need the trigonometric ratio for cosine, and as you can see, we're missing the adjacent side. So we're going to use Pythagorean theorem, a squared plus b squared equals c squared, to find the adjacent side, because we don't have that right now, and we need that. So we got a squared plus b squared is equal to c squared. Now they've already given us two of the sides that we need, so I just got to plug it in. So they give us the opposite side, so if I square that, obviously I'll just get x squared. We're missing the adjacent side, which is going to be b squared, so we'll leave that alone. And then if I square 14, I'll get 196. So if I solve for b, I'll get b squared is equal to 196 minus x squared. Taking the square root of both sides gives me b is equal to the square root of 196 minus x squared. We now have the adjacent side. So we have cosine theta. The adjacent side is now the square root of 196 minus x squared. And we already have what the hypotenuse was. That was 14. Now, again, like I mentioned in other videos, drawing the triangle isn't required. And so we just label the sides, so we know what the opposite side is. The opposite side was x, recall. The adjacent side, which is the side that we found, that was the square root of 196 minus x squared. And then the hypotenuse, of course, was 14. So we go back to what we had after we did the integration. So remember, we got 98 times theta plus 1/2 times 2 sine theta cosine theta plus c. So we plug in sine to the negative first, or arc sine of x over 14 in for theta, and then we'll sub in the trigonometric ratios that we got for sine and cosine, and then we just got to kind of clean it up. We'll distribute in the 98, clean it up a little bit, add r plus c, and we'll pretty much be done after that. So let's just go back to what we had. So let me just write everything out first before distributing. So it'd be 98. This becomes sine to the negative first, or inverse sine, or arc sine, however you choose to say it. X over 14. This would be plus 1/2 times 2. Then we got times x over 14 times the square root of 196 minus x squared. All over 14, and then plus c. Now we just got to clean it up, and we'll actually just go ahead and kill two birds with one stone. Just write the final answer down. So we're asked to integrate the integral of the square root of 196 minus x squared dx. So it looks like our answer, and you'll need to simplify and distribute the 98 in. So we'll get 98 sine to the negative first x over 14. And then, well, it looks like we're going to get plus x times the square root of 196 minus x squared. And then this would be all over 2. And then you just got to add a plus c to the end. And that's your answer. And that's how you do it. Alright, so obviously trig substitution, at least for me, when I was taking Calc 2, was the hardest of the integration techniques for me, because as I've mentioned before, trig substitution, or just trig integration in general, requires that you memorize a lot of trig identities. And although for the trig substitution, the Pythagorean identities are obviously the most important ones to remember, as you can see, the other identities come in handy as well. So not knowing those can also put you at a disadvantage even when doing a trig substitution, because notice that when we got down here for cosine squared theta, we used the half angle identity for that. And when we got down here for sine of 2 theta, we used a double angle identity for that. So just memorizing the Pythagorean identity is obviously very important for the trig subs, but you need to have the other ones memorized as well, so that you'll if you get into a situation, and oftentimes that'll happen, where you need to use a trig identity, another trig identity, such as double angle, half angle, whatever, and make sure that you're equipped with that. And that's pretty much the process for it. So I do have other videos on it, so let me know if you have any questions. But that's going to be it, and I will see y'all next time.